Hello. In this episode, we're going to be looking at simultaneous equations and how we solve the simultaneous equations. So just by definition, we know that simultaneous equations is basically a set of equations that have the same variables or unknowns, which unknowns carry just the same value. Okay. So if you have, let's say, x plus y is equal to 10, and maybe 2x plus a 3y is equal to maybe a number like 30. So we can see that these are two equations, okay? So if we have just two unknowns, we expected to have two equations that we work with, okay? So if we can use the two equations in solving the two unknowns, then the two will be called simultaneous equations. So what we're saying is that the x value in the first equation must be equivalent to the x value in the second equation. Same with the y value. In the first equation must be the same y value within the second equation. But now at our level, in grade 11 and grade 12, what we're gonna have is basically two equations whereby one must be a linear equation, okay? And then the other one would be a quadratic. If it's not a linear, then it has to be in the form of the equation of a hyperbola. You know, if it's maybe y is equal to, let's say, 7 over x, and then the other one must be probably just a linear equation, something of the sort. But in other words, we should be pushing towards getting what we call quadratic solutions, whereby you have at least two variables or values of x and then two values of y, and then we take it from there. All right. So we have quite a number of options or methods that we can use in solving this, but we're just going to use the direct one, okay? So the first approach is just isolate or make some unknown the subject, okay? So the first equation to use will be the linear equation. And from the linear equation, you're going to make something the subject, and then two, we shall have to substitute whatever we made the subject into the second equation. And then we can be positioned to solve our quadratic equation and get the two values that we need. All right, so we have an example here. They're telling us to solve for x and y simultaneously. Okay, so what I'm going to do for this case, I'm gonna start by labeling or baptizing this name. So that's equation one. Let this be our equation number two. Then I can say, since equation one is the linear equation, I can easily make x the subject. I have to move this that side. So x is going to be a positive 3y plus 1. Let me call this equation star. And then we said we have to substitute this third equation or equation star into equation number 2. So where there is x, I'll just replace the 3y plus 1. So that's going to be 3y plus 1, but squared for that part, okay? Then minus 2y. Then where there is x, I'll put a 3y plus 1. Then plus 9y squared is equal to 17. Then from there, what I'm going to do, so we open up the brackets, okay? So that's going to be 3y squared, which is going to be 9y squared, okay? And 3 times 1 is 3 times 2. That's going to be 6y. Then 1 squared is 1. Open this up. It's going to be 6y squared minus 2y plus 9y squared. Let's move the 17. Minus 17 is equal to 0. Then we collect the like terms, okay? So 9 minus 9, 9 plus 9 is going to be 18. 18 minus 6 is going to be 12. So that's 12y squared. Then 6y minus 2y. That's going to be a 4y. And then 1 minus 17, we have negative 16 is equal to 0. So all these can be divided through by 4. So we're going to have y squared It's going to be 3y squared plus y minus 4. Okay. Then what I can do is I can use the factors, or I can use the quadratic formula. Okay, that's equal to 0. Let's use the factors. I'll open my two brackets, but still even at this level, you can use your quadratic formula. Okay, so that's going to be a 3y. I'll have a y. If I put a 4 here, then I put a 1 here. This is going to be a positive. This is a negative. Okay. So I can do this, because that's 3y squared minus 3 plus 4, which is a 1. All right, perfect. So then it's either 3y plus 4 is a 0, or y minus 1 is a 0. So this will give me negative 4 over 3, or y is going to be a 1. So those are the values of y. Then we need to get the values of x just using this equation star. Now from equation star, if I use negative 4 over 3, it's going to be 3 times negative 4 over 3. Okay, and then we plus the 1. That's going to give me a negative 3. So x is going to be a negative 3. And then this side, if my y is a 1, it's going to be 3 times 1, which is 3 plus 1, then it's a 4. So this x is going to be a 4. So you can just leave it like that. This could be maybe 5 marks or 6 marks. Yeah. All right, question number 2. What happens if we have some exponents involved? Okay. So remember the laws of exponents. We need to create similarity within the bases so that we can do the addition and the subtraction where possible. Okay. So if I call this, now let me not call it equation 1 as yet. Let me just look at the first equation. Okay. This is a base of 3. This is a 9, which can be expressed as a base of 3. This is 2, 4, 3, which can also be written as a base of 3. Stand to be corrected. Yes, it can be written as a base of 3. So it's going to be 3 to the 3x over, it's going to be 3 squared with the y, which means 3 to the 2y is equal to 3 to the 5, okay? Then since this is a division, we shall subtract. So 3 is going to be 3x minus 2y is equal to 3 to the exponent of 5. Now, if the bases are the same, which means even the exponents have to be the same. So 3x minus 2y is going to be 5. Okay, let's call that equation number 1. And then let's come to the second equation and do more or less the same thing. Let's create bases of 2, because the smallest base is a 2. So that's going to be 2 to the x. This is going to be 2 squared with y minus 1 is equal to 32, can be written as 2 to the exponent of 5. Then let's plus this since we are multiplying. So that's going to be 2 to the exponent of x plus 2y minus 2 is equivalent to 2 to the exponent of 5. So the bases are the same. Let's just focus on just the numerator, the exponents. So x plus 2y minus 2 should be equal to 5. Let's simplify this. X plus 2y is equal to 7. Let this be our equation number 2. Now, between the two, remember, both of them are linear in this case. So if they are linear, then you can use your substitution or the elimination in that case. So if I use the elimination, now I'm going to use substitution. Let me move this 2y that side. So that x is 7 minus 2y. Let me call this equation 3. And then I'll use equation 3 into equation number 1. So where there is x, I'm going to replace it with that. So it's going to be 3 into 7 minus 2y minus a 2y is equivalent to 5. Let's open up that. It's a 21 minus 6y minus 2y is a 5. Let's move the 21 this side. So what is 6 minus a 21? That gives us negative 15. So this and that is going to be negative 8y is equivalent to negative 15. So which means y is 15 over 8. Then let's get the y substituted there so that our x becomes 7 minus, we're saying 2 times 15 over 8, which gives us 13 over 4. So we're saying x is a 13 over 4. So the trick or the magic around this question was just how do you use the exponential equations to create your simultaneous equations. All right, number 3. Number 3, we have more or less the same thing. Y plus 2x is 1, 2x squared minus y squared is equal to x plus 6. So let's call this equation 1. Let's call that equation number 2. From 1, I'll make y the subject, which is 1 minus 2x. Let's call this equation 3. And then they want us to substitute equation 3 into equation number 2. Okay, so where there is y, we shall just use that. So that will be 2x squared minus 1 minus 2x but squared is equal to x minus 6. That will be 2x squared. When we open the brackets, that's going to be 1 minus 4x plus 4x squared is equal to x minus 6. Then let's just open this bracket with a negative sign. So 2x squared minus 1 plus a 4x minus a 4x squared is equal to x minus 6. Okay, let's collect the like terms. So negative 2x squared plus 4x minus 1 minus x plus 6 is a 0. Then I simplify this further. I'll have just a negative 2x squared plus 3x, and then plus 5 is equal to 0. Then all I'll do is just divide through by a negative so that I have a 2x squared minus 3x minus 5 is equal to 0. Let's see if I can get the brackets, so the factors, so that's 2x and x. For me to get the 5, I'll have the 5 there, I'll have the 1. Since it's a minus, will that make sense? No, it's not gonna make sense because I'll have a 2 times 5, which is a 10. Let me have a 5 and a 1 there. 2x squared, 2, 5. Let me negative, positive. Okay, so which means our x here is gonna be 5 over 2. The x there is gonna be negative 1. So if that is true, then just get these x values, substitute them into equation 3 for you to get your y values, okay? So our y is gonna be 1 minus 2 times 5 over 2. Remember, you can just use your calculator straight out, negative 4. And then if x is negative 1, which means y is going to be just a 3. So that is how we would have solved this third question of ours, okay? Let's look at number 4, and probably the last one. Okay. So with this one, they're telling us to solve the following graphs simultaneously. Okay, so now these are graphs. In this case, this is a hyperbola, okay? And then this is a straight line. Remember, the shape of a hyperbola is something like that, since it's positive. And then if it's a straight line, so which means the two graphs are gonna meet at 2 points. So which means you're gonna have to solve this simultaneously. Good enough or fun enough is that everything is gonna be straightforward here because equation 1 and equation 2 is in terms of y. So which means you're just gonna get equation 1 equated to equation 2. So 2 over x minus 5 is the same as 4x plus 2. Then what we do next is to eliminate the denominator. So you're gonna multiply through by x, multiply through by x, and then by x. So this x cancels that. So 2 minus 5x is equal to 4x squared plus a 2x. And let's create a standard equation, okay? So that's going to be 4x squared. When this one comes that side, it's going to be a 7x minus 2 is equal to 0. Use your quadratic formula or basically your factors so that we can get the values of x. So what I see, if I'm to use the factors, is this, okay? If I have 4x here, then I have a 1. For me to get 2, I'll have 2 there, then I'll have a 1. But this is a positive. So that's a positive, that's a negative, okay? Is equal to 0. This is x. Okay, so which means when I solve this, I'll have 4x minus 1 is equal to 0, or x plus 2 is 0. So this first one will give me a positive a quarter. The second one, x is going to be negative 2. Then I can just substitute these values into any of the equations, okay? I can use this the second equation rather. So 4 times a quarter, that's 1, plus 2, which means it's a 3. And in this case, it's going to be 4 times negative 2, which is negative 8, plus 2, which is a negative 6. So that is how we would approach these simultaneous equations. So these are marks that you cannot let go. So you just have to be very, very, very careful with the negative signs, especially when you're substituting with square brackets as you're opening them up, because any mistake that you make via the opening of brackets will automatically affect the final result. So that is that. If there are any issues, any comments, please just slot them below and we shall chat. Thank you.